In this video, let us look at what is Spearman's rank correlation because we know the limitations of Pearson correlation coefficient. So, we see that Pearson correlation coefficient is not sensitive to nonlinear relationships. Also, for this kind of data, we can use other coefficients like Spearman's or Kendall rank. Let us look at Spearman's in this course. I am not going to discuss Kendall's rank because that will be too much of talking about correlation only in this course, but let us have a feel of what is Spearman's rank correlation. Similar to Pearson's correlation coefficient, Spearman's rank correlation also varies between plus to minus 1, and exactly it is a negative sign indicates there is an indirect relationship between x and y, that is indirectly proportional. If x increases, y will decrease. If x increases, then y will decrease, that is negative sign, and the positive sign indicates if x increases, then y also will increase, so directly proportional. And the values indicates the magnitude of relationship between x and y. If value is more like 0.8 or 0.9, it is strongly correlated. 0.2 indicates the correlation is a bit weak. Okay, the first point, Pearson correlation coefficient between ranks is called Spearman's rank correlation. Spearman's rank correlation is nothing but Pearson correlation coefficient applied on ranks on the variables we use. So, we will discuss that in detail, okay, in the coming slides. So, let us look at that. So, rank of variables then do Pearson's R is exactly what Spearman's rho is. Let us look at 7 students data, and we have attendance and we have final marks out of this. First thing we have to do is let us take this is x, consider this is x and this is the y. Okay. We will do the ranking of the available data, like this is the least, and maybe arrange it in ascending order. And this is the first rank, this is second rank, first is 45, second is 56, then 80, then 85, 90, 95, 100, those are ranks. Similarly, for the max, we can rank, this is the least value I rank, so 1, and the next is 2, and this is 3, and 4, 5. There are two 90, so 6 and 7 we do not want to give, so we can put 6.5, 6.5. Okay. So since we have ranked them, these variables are ranked. If you compute Pearson's R on this rank, that gives you the Spearman's rho. Spearman's rho is this is a rho. The symbol is Spearman's rho. Since I use a different font, it is like that. Otherwise, it's just a rho. There is no line below it. It's just a rho. Spearman's rho and is computed on the ranks of the Pearson computed on the ranks on the variables. Okay, it's very simple. There is other formula instead of using Pearson on this rank. The other formula is very easy. You compute the difference between these two ranks. So the difference between these two ranks is 0, 0, and this is 1.5. It's 2.5. Okay, I am wrong. Okay, then the calculation will be wrong. Okay. Okay, so let us compute it again later, or you can compute it on yourself. So the difference is 2.5, and it's 2, and it's 2, and this is 0.5, and this is 2. So the values will be, if you I just did the mode because I just if it is negative also I consider it as positive, because I just want absolute difference, not the sign. For example, 2 minus 2 0, 4 minus 2 will be minus 0.2.5, but I just put 2.5 just value, and 3 will be minus and will be positive. Doesn't matter, you know, if you wanna consider the square of this value. So whenever if it is minus, it will be positive in the anyway. So 0, 0, 0, 2.25, 4, 4, 0.25, and 4. So you can use this value, the summation of this d square values, and there is a formula to compute Spearman's rho. It's actually the 1 minus That's 6 into summation of d square values, n into n square minus 1. N is actually number of samples, it's 7 here, and we can use this formula to compute Spearman's rho. And this formula is a simplified formula of doing Pearson's or under rank. So this is how you compute Spearman's rho. So let's look at the plot. The plot looks like this for these variables. There is a linear relationship, there's a good relationship from year to year. Let's look at the Spearman's rho value and R value. The rho is 0.74. The rho is 0.74. This is not correct because I used 1.5 instead of 2.5. If you compute it, if you compute this value correctly, 2.5 square, and you add that, sum of it up, and if you add it and you compute in this particular formula, you might get a different value. If you use the difference in ranks and compute this and compute the Spearman's rho using this particular formula, you will get this results. If you simply apply Pearson's OR on this ranks, you will get this value. This value I took it from the website. There is a website which will help you to compute Spearman's rho for free. So I used this data, applied there, I got this value. So this value is not correct. You can compute it and compare. There is a small difference between the values you compute by applying this formula or applying a Pearson's OR on this rank. So I would request you to check what is Spearman's rho in detail, but this is how the Spearman's rho is computed. When we mean Spearman's rho is computed by using rank the variables, then apply Pearson's OR on the rank, this is what it means. You rank them, then you apply Pearson OR on that. So here OR indicates Pearson's correlation coefficient 0.84 is high correlation, but Spearman is not saying it is high correlated because the relationship may not be linear or something is missing. So let us see what is the exact difference between rho and R in an slide. In this activity, I just want you to show how Spearman's rho is sensitive to the outliers. Okay. So now we saw this particular values in the previous slides. I changed two values, that is for a mark CA I changed this to 17, and for the high marks in A I changed this 23. So I made two outliers out of this mark. I just changed myself to create two outliers because every other value is perfectly high score means high score in B, high score in A, high score equal to B. So, but I just changed these two values to show the outliers. Now can you predict, do not need to compute it mathematically, can you predict or guess what will be the Spearman's rho for this plot? Also what will be the R value, like Pearson's correlation coefficient value of this plot, and how it will differ? Can you guess it, and how it will vary for the outliers and everything? If you have done that, please resume the video to continue. So the Spearman's rho for that particular is 0.81, but the correlation coefficient R is 0.34. Because it is outlier, the line tries to fit all the lines and there is a huge difference between the points and the line. So the R value is going low, but rho is good, rho is not sensitive to that outlier. Okay. So it can handle the outliers also. The rank value is used to compute the correlation. Why Spearman's rho is not that much sensitive? Because out of all 60 students data, only 2 data is not correct. For example, in that example 94 and 98, right. So this will be highly ranked 59 and 60. And why the marks are 17 and 23, I am wrong, just a minute, I check it out, it is 17 and 23, yep. So this might have so this might have been a rank number 1 and rank number 2. So, when you compute the difference between ranks, so it might be say 58 and 58, and square of these values might be huge, but when compared to the other values, there are other 58 values which is closely related, it is like highly related. I believe like all the ranks might be equal except these 2 ranks. So, 1 or 2 values. So, there is a value, and if you divide by 60 into 60 square minus 1, this value will be negligible. So, that Spearman's rho is not much sensitive to the outliers like the Pearson correlation coefficient will do. The reason is we are ranking them, we are comparing on the rank, only the 2 values are not matched. So, we try to compute the correlation coefficient as much as good based on how many numbers or how many values are highly correlated, and it can ignore the outliers. So, hope you understand the relationship between how Spearman's rho is computing the correlation in outliers. Also the Pearson's correlation coefficient is considering the outliers when they compute the R value. Let us do the other activity, just make it clear. You see x value in this plot is 1, 3, 4, 6, 7 or some scale between 1 to 10, but the y value is 1, 10, 100, 1000, 2000 like in the log scale or something. If it is 10,000, definitely in the logarithmic scale. And if I want to compute Spearman's rank correlation rho and also R, Pearson's correlation coefficient, what will be the values? No need to do computations, mathematical computations. Instead, based on your understanding till now, try to find out the correlation coefficient between these 2 variables. Maybe the linear relationship will now connect some lines like this, and that might have some different points, and Spearman's will do differently. Can you guess the rho and R value? After doing that, please rush him to continue. The R is I am sorry, the R value is 0.87 positive, and it indicates it is highly correlated, but some points are not linearly related with x and y. If x increases, y also increases, but not fitting in that linear relationship, the linear line. But rho indicates 1, it means for all the incremental in the x, y also increases. They may not be in the linear scale of increment, but there is an increment in x, there is a y is incremental. So, 1 indicates whenever the x increases, y also increases, maybe the different scale, but there is a relationship, that is why rho is 1. So, this indicates rho can handle if one variable in a different scale, a logarithmic scale, and x in other scale, it can even able to identify the correlation coefficient, because we add a rank. You understand, right. So, if you compute the rank of the values in the previous plot, you get exactly the similar rank. So, all the ranks are same, if you find a difference it will be 0. So, you get 1 minus 0, it will be 1, that is how the rho is computed. But the Pearson's correlation coefficient will try to indicate 0.87. So, I just want to show that in the previous slide. If you just compute the rank, the x rank will be rank of x will be 1, 2, 3, 4, 5, rank of y will be 1, 2, 3, 4, 5. So, if you find the difference between these 2 values, definitely it is 0, and 1 minus 0 by whatever value it will be 0. So, 1 minus 0 is 0, or if you compute a Pearson's R on this value, it is kind of a self correlation, it is definitely 1. So, that is why the Spearman's rho is 1, but the R value is not 1, R value is trying to fit a line, maybe the line kind of trying to fit like this. There is a small difference between these lines, values in these lines, that is why it is 0.81. Hope you understand what is Spearman's rho and correlation coefficient, Pearson's correlation coefficient are.
So, which one to choose is very important, and can I just go and use coefficient as the values to prove my algorithm or hypothesis or my inferences? I would like to say it is not the case. So, first always visualize your data. As we show the figure, diagnostic analysis means you should have done the descriptive analytics also. Visualize the data and see is there any outlier, what are the relationship between x and y, is x and y in the same scale or linearity, all these things, then you can choose which correlation coefficient you want to report. Most widely Pearson's correlation coefficient is used if it is values or both are nominal, it is good. If one of the values ordinal, people use Spearman's rho. So, look at your data, visualize, since you know the math behind both these correlations Spearman's and Pearson, now you know which one to choose based on your data. So, visualize it and decide, and also consider non-linear relationship between these data, then pick the right correlation coefficient. If you are doing it, show it why you are picking the right correlation coefficient, explain to others and use that value. Most important is correlation, it is not causation. Correlation indicates just what is the relationship between x and y. If s increases, is y also increasing or decreasing, that is what the correlation is indicating. Never use correlation as a causation. It never tells that y increases because of s increases. No, there is a correlation between these two variables, but it never tells causation of why y is increasing. So, never use the correlation coefficient values to prove your causation in your theory. Okay. So, in this video we saw what is Spearman's rho, and we also saw what is relationship between Spearman's rho and Pearson's correlation coefficient. Hope you understood both. Thank you.